Hello students, in today's lecture I will discuss about perspective projection. As I have already said that projection is basically it is the display of three-dimensional object on a two-dimensional view plane. And we have already seen that there are two types of projection. First is parallel projection and second is perspective projection. In parallel projection the lines are parallel, the projection lines are parallel while in case of perspective projection the projection lines are converging at a point which is called as projection reference point or center of projection. For a perspective projection, object positions are transformed to the view plane along lines that converge to a point called the projection reference point or center of projection. So here you can see in the figure that we are having one line having dimensions p1 and p2, and these dashed lines are basically they are the projection lines and they are intersecting at the view plane. The intersection points defines the new coordinate of the object, and after some time the projection lines are converging at a point which we are calling it as a projection reference point. The projected view of an object is determined by calculating the intersection of the projection lines with the view plane. Now, perspective projection gives realistic views but does not preserve relative proportions. So in this case what is happening, we could get a realistic view of an image but the dimensions of the object is not preserved. So perspective projection is not applied on engineering applications uh, because the drawing dimensions of an object has changed, but we could able to see the realistic image of a picture. Projections of distant objects are smaller than the projection of objects of the same size that are closer to the projection plane. So the objects which are closer to the view plane appears big, and the objects which are far from the view plane appears small if they are having same dimensions. Now we transform points along the projection lines that meet at the projection reference point. So here in the figure we can see that we are having an object p x comma y comma z, and we are having one projection line, and after some time the projection line is intersecting on the view plane and the coordinates will be xp yp comma zp. Zp is basically it is the position of the view plane along the z-axis, and zprp is the projection reference point on the z-axis. Now suppose we set the projection reference point at position zprp along zv axis and we place the view plane zv as shown in the figure. So here what is happening, we are placing the view plane at the point zvp and we are placing zprp, that is the projection reference point, at this point. Okay, so if the distance between zvp and zprp we are varying, the dimensions of object is also changing. Now we can write the transformation equations as x dash is equals to x minus xu, y dash is equals to y minus yu, and z dash is equals to z minus zprp into u. So here we are taking one parameter, and the parameter could have value which lies between 0 and 1, and at u is equals to 0 we are at position p is equals to xyz, and when u is equals to 1 we are at position 0 0 zprp. Now on the view plane z dash is equals to zvp, as we know that the position of view plane is what it is, z dash, and the value at that point is zvp. And now we are solving the equation for z dash, and we can solve the z dash equation for parameter u at this position along the projection line. So from here, from the equation number 3, here you can see that we are having the value z dash is equals to z minus zprp into u. From this equation what is happening, I am calculating the value of u. So the value of u becomes, I am substituting the value of z dash as zvp, so I will get u is equals to zvp minus z upon zprp minus z. Now substituting this value of u in the equations of x dash and y dash, we get the transformation equations as xp is equals to x ZPRP minus ZVP upon ZPRP minus Z, which gives X is X into dP upon ZPRP minus Z. Similarly, we could able to find the equation Yp is equals to Y into dP upon ZPRP minus Z, where dP is the distance between ZPRP and ZVP, that it is the distance between the view plane and the projection reference point. Now, using three-dimensional homogeneous coordinate representation, we can modify the above equations and can represent them in the matrix form as XH, YH, ZH, H is equals to matrix 1 0 0 0 0 1 0 0 0 0 minus ZVP upon DP, ZVP into ZPRP upon DP, 0 0 minus 1 upon DP, ZPRP upon DP into XYZ1, where H is basically what? It is a homogeneous factor and the value of H is given as ZPRP minus Z upon DP. And the projection coordinates on the view plane are calculated from the homogeneous coordinates as XP is equals to XH upon H and YP is equals to YH upon H. Here we are preserving the value of Z, where the original Z coordinate value would be retained in projection coordinates for visible surface detection and other depth processing. So this is all about today's lecture. Thank you.